Hi, my name is Tyler, and today we're going to be talking about helicopter performance. We're going to be talking about factors that adversely affect helicopter performance, and that is any factor that affects the engine or rotor efficiency affects performance. And the 4 H's, you've never heard of that before. I'm sure you'll hear about it and you'll continue to hear about it, but that's hot, heavy, humid, and high. Now we're going to be talking about heavy, or the weight aspect of the performance today. So simply put, if a helicopter is heavy or has a lot of cargo or personnel on board, it's going to require more lift to fly, and that's going to affect the performance compared to a helicopter that was light with the same engine. So looking at some terms here, just to kind of get us all on the same page, we got weight, which is the force of gravity on objects. So weight, we got basic empty weight, which is the starting weight for calculating helicopter weight and balances. And the basic empty weight is a standard helicopter weight with optional equipment, unusable fuel, and full operating fluids, and full engine oil. Max gross is essentially the same, other than it's got the payload, which is the pilot, the air crew, cargo, and usable fuel on board. So now then we talk about load factor. And the load factor is the ratio between the load supported by the main rotor system and the actual weight of the helicopter. I have a diagram here, kind of talk about, we got a vector here demonstrating the weight, and here we have centrifugal forces. So as the helicopter turns, these are aerodynamic forces or centrifugal forces that add more weight to the main rotor system. So the load factor is the difference between the load of the helicopter that the rotor's supporting and the centrifugal forces that add to the weight of the helicopter. And an example of this is that a steady state flight, helicopter has a load factor of 1. If it enters a 60-degree bank and maintains its altitude, it's going to have twice the load factor. It's going to increase the load factor by 2 there. So it's going to have a load factor of 2. And those are the aerodynamic loads imposed on the rotor system. So going into the R22 weight limitations a little bit here. Max gross weight limitation of the R22 is 1370, and the minimum gross weight is 920. And then we can get into per seat, but we won't get into that. But so as you can see, there's a maximum and a minimum. So either too much or too little can create unfavorable flight conditions. For example, if the reason for the minimum gross weight, if you, in the event of an engine failure, you need to enter an auto, if you're below 920 pounds, it's possible that you're not going to be able to maintain the required rotor RPMs for a safe auto rotation landing. And a question I have for you is, can an R22 pick up overloaded higher than 1370? And the answer is yes. But the reason that the POH has these limitations is because operating above the max weight limitations compromises the structure integrity of the helicopter and adversely affects performance. And ways that it adversely affects performance being overloaded: longer takeoff run. If you're overloaded, it's going to require a longer takeoff run. Both the rate and angle of climb rate is going to be reduced. Service ceilings will be reduced. Cruise speeds and cruise range will be reduced. By the VNE speeds, you'll approach VNE much sooner than you would if you're overloaded and using the charts in the POH, because they're off of the helicopter being 1370. for max gross weight. Cruising range will be shortened and removability will also be decreased. Another structural limitations are based on operating helicopters below max weight. Operations above max weight could result in structural deformation and failure during flight if you encounter excess load factors, like we talked about with the load factors, strong winds or gusts, or even moderate to extreme turbulence could cause these structural failures if you're overloaded or over the max gross weight. Another thing that you'd have a higher risk if you're over max gross weight is emergency situations. For example, retreating blade stall or low rotor RPMs. You're more susceptible to these situations being overloaded. Another thing that I'd like to point out that I think is pretty interesting when talking about weight and loading helicopters here is the actual visual that you can see on a rotor system as it's being run up and lift is being applied by the increased bank angle. You start to get this coning effect, and this coning effect is the upward bending due to the centrifugal forces and lift, and you start to get this bend up. And you can see that while you're watching a helicopter run up on the ramp. As they start pulling collective, you're going to see them blades start to cone up, and the more a helicopter weighs, the more coning you'll see. And this is a diagram of the adverse effects of excessive coning. As you can see here, decreases the total lift because the decrease in effective disc area. So as the coning continues, for example, if you were overweight, the effective disc area is smaller than if you were, lower coning area. So you're going to have a decreased lift here because of the increased coning, and that can be caused by G-forces, excess G-forces, and being over gross weight like we talked about, and RPM gets too low and requires more lift. You're going to have excess coning. But once again, just going over weight, and the review is basically, that you have to follow the POH limitations and weight limitations because they're there for a reason. And if you have any questions, please let me know. Thank you.